Unit 1, pages 5 through 8, Dimensional Analysis. First, recall what a conversion factor is. 1 gallon is equal to 3.785 liters. These are both equal amounts of volume, except expressed in two different units, and so this is a conversion factor. It's often used as a ratio. This ratio could be written in two ways depending on how the conversion factor is needed in a particular calculation. So you could place the 1 gallon in the numerator over 3.785 liters, or you can do the inverse. To convert 5 liters to gallons, the calculation below would be performed. So here we have 5 liters to start, and I need my liters to cancel, and therefore I'm going to have the liters at the bottom of the ratio and gallons at the top of the ratio. Because remember, this is essentially liters divided by liters, which cancels out. And this is going to equal 1.321 gallons. Notice that the conversion factor was used in such a way that the units canceled to give the answer in the desired units of gallons. If the conversion factor is used incorrectly as below, the units in the answer would be incorrect. In this incorrect calculation, the units come out to be liters squared per gallon, which is not the desired result. So here, if you would have placed gallon as the denominator of the ratio, then what happens is the liters times the liters in the numerator is going to give you the liters squared over, and gallons is not canceled in any way, so it would be in the denominator here, which is incorrect. Valuable tools for careful workers. Make it a habit to always use dimensions in your calculations. Careful workers always ask themselves if the answer makes sense. Example 1.3 will calculate the mass of gasoline in a full tank with a volume of 15.0 gallons. This is my starting value, 15.0 gallons times, draw a line. I know that I want gallons to cancel, so I know that I will have gallons in the denominator, and notice we're provided with a conversion factor from gallons to liters. So I can place gallons in the denominator, 1 gallon, and 3.785 liters in the numerator. This way, gallons have canceled, and now I'm at a unit of liters. Times, draw a line, and I'll bring liters down. Now, I'm trying to get to mass. That is my goal. And anytime you want to get to a mass, you want to use a density. From a volume to a mass, you want to use a density. Here we have 0.703 grams per milliliter. So this tells me I need to get my liters to milliliters first in order to use this conversion factor. So we'll go to milliliters. 1 liter is equal to 1,000 milliliters. This makes my liters cancel. Times, draw a line, and now I can bring down milliliters. And here I can use the ratio that for every 1 milliliter, there are 0.703 grams. Remember, this is 0.703 grams per milliliter, or per 1 milliliter. And so here milliliters will cancel, and I'm at the unit of grams, and that would be the mass that I'm trying to determine. In order to calculate our answer, we'll take 15.0 gallons, and we're going to multiply by the numerator, 3.785, multiply by 1,000 in the numerator, and multiply times 0.703. And this is going to give us a value of 39,912.825 grams. If I'm looking at significant figures, you do not use conversion factors, and volume is 15.0 gallons. Therefore, I want this to be rounded off here, which would give us 39,900 grams as our final answer. When converting cubic units, we have to take into consideration that the conversion factors we tend to use are for a length. However, cubed units or volumes tend to be a length times a width times a height, which means that you can't just use a length, you have to use that length cubed. So to convert 15 cubic centimeters per minute to units of cubic meters per second, we must convert centimeters cubed to meters cubed and the minutes to seconds. Focus your attention on converting 1 unit at a time. So here we take the 15 centimeters cubed per 1 minute, and let's just convert the centimeters cubed to meters cubed first by bringing down centimeters, and then we're going to go to meters. 1 meter equals 100 centimeters in length, but I'm going to cube these values. And so that's actually going to give me 1 cubed, which is just 1, meter cubed, divided by 100 cubed centimeters cubed. So everything is cubed in the parentheses. The 1 is cubed, but that's just equal to 1, so I'm not going to write the cubed. So when I take 15 divided by 100 cubed, here, then that's going to give us 1.5 times 10 to the negative 5, which is here, cubic meters. We're still per minute, though. We want our answer to be per second. Now we're going to convert the minutes to seconds. So here's the answer we got so far, cubic meters per minute. Remember, this is the same thing as writing per 1 minute. And I'll just scratch this out right here. So I want to cancel minute, and therefore I'm going to bring minutes up to the numerator in my next step, which is going to allow minutes to cancel. And we know that 1 minute is equal to 60 seconds. Therefore, you're going to do 1.5 times 10 to the negative 5 divided by 60, because it's in the denominator. And that's going to give us 2.5 times 10 to the negative 7 cubic meters per second, which is the units of the final answer that we're looking for. Density is a physical property that measures the mass of an object per unit volume. The density of gasoline is 0.703 grams per milliliter. Just by inspecting the units, you should be able to guess that density is a physical quantity that connects mass and volume. Solid styrofoam has a low density and lead has a high density. A brick-sized piece of solid lead has a mass of about 20 pounds due to the high density of lead. A styrofoam brick of the same volume would have a mass of about 400 times smaller than the lead brick. Density can be used as a conversion factor in these two ways. So you can look at it in this form, and you can turn the 0.703 grams per milliliter into a ratio. 0.703 grams per 1 milliliter, or for every 1 milliliter there is 0.703 grams of mass. So it can be inverted as needed. So density is going to let you convert from a mass to a volume or from a volume to a mass, depending on how the setup of the problem is. Here's your note card for this section, that in dimensional analysis, when you multiply units, they're going to combine, like centimeters times centimeters equals centimeters squared. When you divide units, they're going to cancel, like liter squared divided by liter is going to be liter. When you have a length, 1 meter equals 100 centimeters, if you want it to be a volume, you have to cube those values, and you're going to cube all of the numbers and the units in the parentheses. And then finally, remember that density is a conversion factor that allows you to convert between mass and volume, or from volume to mass.